Great. So for those who don't know me, I'm Antoine. I'm a senior software developer at TriggerMesh and occasional contributor to Knative eventing as well. And in this presentation, I would like to show you how we try to simplify the way we describe service integrations on Knative by designing a small description language that we call the TriggerMesh integration language, aka TIL. So the next 30 minutes will be split in 4 different segments. First one will be a quick overview of what we do at TriggerMesh and how it is relevant in the context of Knative. Second one will be about the challenges that led us to considering creating this language. In the third one, I'm going to talk about the goals, the non-goals of the language, and finally, I will give you the demo. So the demo will be the longest part of the talk, of course. Right. So broadly speaking, what is TriggerMesh? TriggerMesh is a cloud-native platform for service integration that is powered by Kubernetes and, of course, Knative. So service integrations are very relevant nowadays because the typical enterprise has to deal with a multitude of software solutions on a daily basis. So concretely, if I show you this slide, I'm sure your own company has at least one integration scenario which involves some of the software products. So at least a cloud provider, I suppose, maybe some SaaS solutions too. And at TriggerMesh, we do believe that developers will build event-driven applications that integrate servers from multiple SaaS, cloud provider, on-premises application. And our customers that tell us that integrating across this mix is a huge challenge, right? So existing integration approaches are slow to implement. Anything which is multi-cloud usually requires several weeks of work, sometimes a lot of consultants as well. And also integrations aren't exactly self-service, and often they are brittle, difficult to maintain, and so on and so forth. So here at TriggerMesh, we set out to answer one question, which is how can DevOps team more efficiently integrate this growing mix? And it turns out that Knative is a great answer to that. So being powered by Knative means that we do write integrations which are conformant to Knative's APIs, such as writing event sources for various third-party services, writing data channels, which are based on cloud services like Amazon Kinesis, Azure Event Hubs, and so on. It also means that our message format is, of course, fully compatible with Knative Eventing's communication protocol. So we do use cloud events over HTTP for everything we do. And being based on Knative finally means that we do embrace the declarative resource model provided by Kubernetes. So you can declare service integration using an API, which now has become ubiquitous. So that's it for the little introduction about TriggerMesh and setting the context about what we do. Now let's talk about the actual challenges that led us to designing this description language. So I will run you through the thought process by describing a simple integration between 2 cloud-based storage services and Slack. And we call this type of integration a bridge at TriggerMesh, but at the end of the day, it's just really like a Knative service integration with event sources and event targets on the other end. And I will also show you how one would go about deploying it to Knative. So first of all, if you were to deploy this kind of integration on Knative, you would go about defining event sources and event targets, right? So for people who are not familiar with Knative eventing, an event source is pretty much an adapter to a third-party service that sources events into the Knative system, into an event-driven system. And the target is what is actually going to consume those events at the end of the chain. So it could be a simple event sync that will store this data, or in some cases, so especially in the case of service integration, it's about interacting with a third-party API as well. So in this case, Slack. To do this, you have to define event syncs, right? So the source have to know about what kind of Kubernetes object there will be on the other side. So if you have an event source for Amazon S3, the event sync is a Kubernetes object in a certain API version, a certain kind, a certain name. By defining them, you allow the source to send events to this destination. But there is a challenge here, right? Wait a second. what if you want to do some queuing and have some delivery guarantees and so on? We were speaking about event-driven architectures before. So far, this is not event-driven. So for this, you add something called a data channel for storing your events, ensuring that these events are queued. If the target is not available, they will be delivered, maybe redelivered in case of errors. But that is not enough in terms of Knative API object. You have to define a subscription for this so that events that go through this channel are actually sent to the target. So you do the same as in the source, right? You defined a relationship to different Kubernetes objects in the shape of a subscriber. You have to define exactly what channel you are subscribing to. And this takes the same kind of approaches of knowing, exactly what API version the objects are in, what kind they have, and so on. Okay, and by doing this, you also, but now you change the reference to the sink in your sources. Your events are propagated to your channel. But now comes the next challenge, which is I need to transform this data because my event sink here is Slack. Slack will definitely, Slack users definitely don't want to see a huge JSON payload in their channel because that wouldn't be very human friendly and it would be really hard to consume for people who use Slack. You know that this is a messaging solution or a communication solution, a chat, and you want to see your message formatted in a certain manner. So you need to operate a data transformation. And this is very, very common in integration scenarios. So you do create some functions, two functions, namely because the data payload is not the same between Amazon S3 and Azure Blob Storage. So one function will be responsible for converting a certain data payload into a Slack message, so a formatted Slack message, and the second one for doing the same for Azure. But you also want to have the same delivery guarantees as before between your source and your target, right? So you add event channels in the mix so that you also have some queuing, event delivery guarantees, and so on. And rapidly, your system will look like this. And what that means is that you have very tangled relationship between Kubernetes objects. You really need to know what a doc type is. You need to know how to use them. And this can be quite complex, right? Especially for people who don't use Knative on a daily basis. And the result of that is, the point I want to get through here is that even by using a declarative approach, building a system like this one, which is rather simple, still requires some intrinsic knowledge of the Kubernetes API and of Knative doc types. So like I said, tangled references between API objects, hard to maintain. YAML is not exactly user-friendly in cases like this. So if your software stack is already has a fair share of moving parts, then all of this is yet another level of complexity on top of that. And what you really wanted was definitely not this, but you wanted to think about your system, to reason about it more from this perspective of I have event sources, they might be dispatched to different functions and they end up in my targets. That's really what you want to think about as an integrator. So of course, some of you may point out that some parts of the system I described before could be simplified by using a broker instead of individual name channels like this, but chances are that your integration at this point is still a wall of YAML, right? It's still not tackling the challenge that your system is hard to describe.
All right, thanks, Antoine.
Okay, so second non-goal was we didn't go into secret management. So we still do believe that admins are responsible for provisioning secrets inside Kubernetes. I know that you do that with a secret object, but this is really not the point of the integration itself. We want to really focus on what I explained before and not on the technicals. So in the same train of thought, we don't want to do the configuration of Knative in this language. Like we don't want to allow people via the TriggerMesh integration language to configure things like the default broker type or default channel type in their Knative installation, right? This is definitely not the point. And we decided that we wouldn't do things like building code, pushing container images to a cluster, because there are things which are more adapted to this, like Boson, for example, like Omer talked about before. So we like to think about the TriggerMesh integration language not as an alternative syntax for writing verbatim Kubernetes API objects. We're not trying to replace YAML with something better or something different, but rather create a collection of abstractions which are inspired by enterprise integration patterns. So to quote the authors of this integration, enterprise integration patterns, which are Gregor Hoppe and Bobby Wolf, this is a collection of integration patterns to establish a technology-independent vocabulary and visual notation to design and document integration solutions. So to keep it short, they describe different styles of software integrations which software architects can refer to in order to design their systems. And the ones we're interested in at TriggerMesh focus on asynchronous messaging architectures, aka event-driven architectures. And at the end of the day, what we want to do is to let you compose your own messaging pattern or messaging systems using the power of this messaging patterns. So we do this usually in two ways. One of the way is to take different Knative objects, such as the brokers, the triggers, combine them into patterns such as event routers, so that they can be described as a single entity and not, like I explained before, a channel and several subscription or a broker and several triggers. Now you can have an object of type a router, which is not, it is not a Kubernetes object, but it can be expressed in the TriggerMesh integration language as a single block. So yeah, first way, combining Knative objects. Second would be to create, in some cases, our own messaging building blocks using this time a Kubernetes object or a CRD. So for example, to do message filtering or data transformation, which the core of Knative is not able to do right now. And directly inspired by those patterns, the ones I described, we have segmented the messaging components in 5 different categories. So you of course have event sources and event targets, right? This is the basis of a service integration. But you also have now message routers, which are responsible for dispatching events to different destinations. You have data channels. So data channels are responsible for doing asynchronous communication. And you have data transformers, which you can also interpolate between components to do transformation on the actual data of an event. Okay, so beyond this declarative aspect, we reuse some concepts from infrastructure as code, meaning by declaring connections in the TriggerMesh integration language between the messaging components, we can, for example, reason about the entire messaging system as a directed graph. And exactly like one would do to declare a connection between cloud services and infrastructure as code solutions, for example. So this allows 2 things. The first thing is to determine the relationship between the Knative components and resolve their addresses in a certain order. So for example, an event source needs to know the address of an event target ahead of time in order to send messages to it. I mean, in terms of object resolution, not in terms of runtime. We also are able, doing this, to understand the data flow within the entire system ahead of the actual deployment. So ahead of the actual deployment. So we can report potential errors to users before the system is even deployed to Kubernetes using some static analysis. So what that means concretely is that we can observe that a certain source is sending an event type to a target. We can check if the target actually accepts that. Or we can, for example, ensure that the event type when it goes through a transformation, a certain event type is transformed to a different event of a certain type. We can check that this is also consistent across the system. Right, so that is it for the first 3 parts. Now for the second half of this demo, of this presentation, I will actually do a demo of the TriggerMesh integration language for this breach that I talked about before. So on one side, event sources for cloud storages, sending events to Slack via a data transformation, all in an asynchronous manner. So like I said, we have a breach, which is going to do an integration like the one you see in this diagram. So we have event sources, which are on one side, Amazon S3, sending events when a blob or a file is created inside a bucket or deleted from the bucket. these messages are going to be sent to a single router, and the router is responsible for dispatching the events based on their source or their event type in this case. So they will be dispatched to different functions. The functions are data transformers, and they are responsible for basically formatting these messages in a way that is consumable via Slack. So we will take a JSON payload coming from these two services, these two event sources, transform them, send them to a data channel where they will be consumed by the Slack application and shown to the users in the data in a Slack channel. On top of that, I really like in demos to really show the event flow in real time. So I injected a sort of wiretapping a SOC-I service. So SOC-I has been created by Scott Nichols. It's a web UI to basically show you events, cloud events, which are being received. So by creating a router here, we will have different rules, which I will show you. Some of them have basically conditions on the attributes which an event should have. But in the case of SOC-I, for example, we have a simple route, which is, like I said, a wiretap, which means it will send every event to SOC-I. So let me go through a little the syntax a little bit. So a bridge is declared by basically a bridge block, where it has to have a name. This is nothing special in terms of integration itself, but it will have an influence in what is actually generated in terms of Kubernetes object by creating certain labels, for example, or packing objects together inside TriggerMesh bridges. So an event source is really no different between the YAML syntax and the HTL syntax, because you cannot really remove the configuration of the actual spec of an object, right? So an event source typically has different attributes that you need to configure. For example, in the case of AWS S3, you need to pass the ARN of the bucket that you want to target. So concretely what it is if you see my web browser, I've got this AWS bucket, which I want to target. I want to source event from it. I have to pass this reference to my description, right? This is the very minimum. You also have, in some cases, to define the event types you want to subscribe to. So I want to know, for example, when an event or an object has been created in my bucket, but I'm not necessarily interested in delete events, for example. And then comes something which is actually special to the language, which is the simplification of the credentials. So in the YAML format, you would typically go about defining credentials by passing this very complicated block of, you have a source, you have a key, and a couple of attributes which define where this secret is coming from. And this is very ingrained into the way the Kubernetes API works, because you have to know that a secret reference needs a name. For example, the name is the name of a Kubernetes object, and that the actual value is going to come from a certain key. And there is a concept of secret classes, which is present in the Kubernetes documentation, but not really advertised, which basically assumes a certain shape for a credential. So in the case of an AWS secret is composed of an AWS access key and a secret access key. And by doing this, we know that what shape your secret should have, and we can reference it as a single call to a function, which is going to translate it in terms of Kubernetes object. I will show you what it means in terms of translation, but the second thing I want to point out is that where we used to have very complex reference to Kubernetes object before, which was in the case of a source, for example, an event sync. So an event sync was also likewise assuming that you have a knowledge about what object type, what API version you're targeting, right? So if I want to target a broker, I have to know that it is in the eventing knative.dev v1 API and that it has the kind broker and a certain name and so on and so forth. So this can be very technical for somebody who wants to simply integrate different services. And we simplified that, like I said, by doing the service resolution, the conversion to a graph, and analyzing the reference or the dependencies between the different components. We allow you to simply target a component by its type and its name. Okay. So typically what's happening here, I have a source, which is, I'm sourcing events from an AWS S3 bucket. I'm using certain credential, and all the events which are going through this source are going to send to a router called dispatch. So what is a router? This is actually a little novelty for this language. A router is sort of abstracting away the complexity of Knative brokers and triggers by providing you a single configuration block where you can define different routes. So think about it as a broker where you would create one separate trigger object for each subscriber that is interested in those events. You do it in the TriggerMesh integration language by defining different routes here. So I have a route which is filtering events based on the source, which is the AWS S3 bucket, and I'm sending them to a transformer. So a transformer is simply a function that transforms the payload by referring to it not by API version and kind and name, but simply by an internal reference in this file, which is transformer.the name of the transformation, namely AWS S3 to Slack in this case. So let's take a look at this transformer. So this transformer is of type function, which means I can pass code basically directly in this block, and this code will be interpreted as a Knative service in my cluster when this will be deployed. So I have here a function call, which is reading a file on the file system, and this file contains code of a Python function. So it's a very, very simple Python function, which is essentially giving the name of the reference to a Slack channel. So yeah, I will show you that later. And I'm operating here really the data transformation. So what is happening here? I'm taking the event coming from S3 and I'm reading the name of that event. So in case of S3, this is going to be what actually happened, if it's a creation, the deletion, and the date. I am also reading the bucket name from this payload. So it is nested under S3 bucket name. Same for the object name. It will be nested under S3 object key, right? So if you're familiar with Python, this is extremely simple. This is interpreted. Of course, there are some limitations, like you cannot really import third-party libraries and so on. But for the typical data transformation, this is more than enough. Okay, so you have this transformation block in the language, and you can use it to generate the Kubernetes object on the other side. So yeah, so the same concepts basically apply to everything, right? So in every block that you have, if this block is processing any kind of event or sending any kind of event, you will have a reference to another internal object or another block defined in this file. And the final destination here after this transformation, for example, will be something called a target chat notification, which is nothing else than a Slack target. Okay, so let's generate that using the till tool. So I'm simply going to pass this bridge brg.htl to till generate. What's going to happen is my configuration is going to be analyzed, validated, and the reference between the different components are going to be built. And from that, the tool is going to generate basically the wall of YAML I was talking before, where you will recognize, for example, that you have event sources, so AWS S3 source. A couple of things have been generated for you, so namely the credentials. The credentials were referring to just a secret name, and because this is a source of type S3, we already know the shape of the secret. So this is very opinionated, but generated on your behalf by the language, by the interpreter. The second thing is, remember in the S resource, we were targeting a router object, which I said was an abstraction on top of Knative's broker and trigger. This has also been resolved here to the right type of object in the right type of, in the right API version and so on. So you really don't need to know in what API versions and what kind you are actually targeting. And remember, we never really described a broker in this language, but we actually described something called a router. And if you search the generated description here, you will see that what we used to call a content-based router is now a broker of name dispatch. And we generated automatically the triggers which are responsible for, filtering on different attributes, sending to the right subscriber, and so on. Okay, so here we have a filtering based on, this is for Azure Blob Storage. This is a very long resource ID. And in the case of AWS, we are filtering on the ARN of the S3 bucket. And if you remember, we also defined a function for doing the data transformation. So this is something that TriggerMesh added in the shape of a function kind running in Kubernetes. So we have a controller which reconciles this type of object by doing something very simple. It's simply passing the code, the interpreted code we defined here in the shape of a Python function to a Knative service, which under the hood is a kind of pre-built, an image which has been pre-built by TriggerMesh to interpret that code. So we have runtimes for Python, we have runtime for Node.js, and also for Ruby currently. So all interpreted languages. And the goal is really to operate this kind of data transformation very simply. Okay, so like I said, this looks very much like a wall of YAML right now. But there are a lot of things which have been very much simplified by using this syntax. Another of my favorite thing is that for the troubleshooting tool that we use often, so for example, sockeye, we have a block of type sockeye, which is a target type. I mean, it's in the target category of type sockeye. By simply defining this block and giving it the sockeye type, you may have seen that we did generate another Knative service, which contains, where is it? Which points to Scott's image sockeye07 here. All right, so this is something we use very often, and this is the kind of little abstraction we can provide you. So let's see if this actually deploys and works. So I'm going to do another till generate on this bridge, but this time I'm going to pass it to a tool which is cap. Wait a second. I'm going to deploy it using something called cap. So cap is a tool created by VMware. It's a very convenient sort of Helm-like tool to deploy applications to Kubernetes. So what I'm doing here is I'm simply calling cap deploy on the output of till generate. So till generates, pure Kubernetes object that can be directly deployed by the tool of your choice. When I said we are not opinionated and we actually don't want to take care of the deployment, this is what I meant here. You could do the exact same thing using Helm or using kubectl or Kustomize or even Terraform if you wanted to, but for the sake of this demo, I'm going to use cap. So you can see that all the objects that we define in our bridge are going to be deployed. We have event sources for Azure Blob Storage, for AWS S3. We have our broker, multiple triggers. We have a sockeye service. And last but not least, we have our function, which are doing the data transformation. All right, so my objects are going to be deployed to the cluster. And what I'm expecting to see here is, well, sockeye on one end. My S3 bucket should have been configured with an event notification here. So it's sending messages over a SQSQ. On Azure, this will be visible as let me remember. In a storage account, this will be visible as a event configuration. So here, if I go to events, I should have an event subscription, which has also been created, this time going over something called Event Hub. And I also have my Slack channel, which should be receiving events now. So I hope this is visible. This should be. So what I'm going to do now is I'm going to conclude this little demo, I'm going to upload and delete files from both Azure and S3 and confirm that the events are both visible in SOC-I, so in this web interface, and confirm that they have been transformed and that eventually they will land inside my Slack channel. Okay, so let's start with S3. I'm going back to my bucket. Knative Meetup. I'm going to upload a very cool thing, the Knative logo. Right, so I'm switching to SOC-I. Boom, my payload has been received. It's just basically showing you what went through the system, but it's not the final destination of this event because it has also been found out by the router to a function. And if everything went fine, yes, my function has transformed the payload and showing, you know, the output of my Python function, which is what event has been sent from S3. So object created put, in what bucket and what object. The same should have happened on Azure. So I'm going to upload, well, the TriggerMesh logo this time. Okay. I'm going to SOC-I, and it hasn't been received. The demo gods are not with me today. Okay, let me look very quickly what is going on there. Okay, so I'm going to show you what I'm doing. We have a type function like I explained before. These two functions are showing as ready, but I don't know, maybe something is not working as expected if I look at the log of those files. I think I know what's going on. I think the blob storage source might not be ready. Yes, it is. Let me try that one more time. So the blob storage source, I will just restart the pod. I will do this experiment again, but this time delete the file. Oh, well, good enough. You've seen that it works with S3. I wish I could have shown it to you, but never mind. Okay. Anyway, does anybody have any question regarding the bridge itself, or should I conclude and then ask for questions?
I think Carlos has a question. He's asking if you are using a function as transformer or TriggerMesh Bumblebee, data plane component.
No, we are using the Python function here. So it's really, I really used a inline code here, or not really inline code, but if you look at my transformers, so I have two transformers here. One of them, I mean, both of them are of type function, which means that this function is this function object being deployed to Kubernetes with inline code, and this code is directly interpreted by the runtime. So what you see here is basically what you get. This is not declarative in this case, but it's imperative. So I'm writing actual Python code, and I would do the same in Node.js or Ruby, for example. So
you have two triggers?
I have three triggers. So these three triggers are coming from the router. So the router has three routes. One of them is filtering events coming from S3, sending them to a transformation. The second one is filtering from AWS, from Azure, sending them to a different transformation. And the third trigger is sending to sockeye. And it doesn't have, you see, a filter on attributes. So it's basically sending every message. So this is the equivalent of a naked trigger, right? Without filter.
And remind me again, you have some CRDs for TriggerMesh, but those CRs are not in the data path, right? They're not in the data plane. They're just like to reconcile the functions.
Yeah. So the functions, yeah, go ahead.
The functions, and you had another one, but I don't know what it was a name, another TriggerMesh describing this. Or it's not in the system. That was just for the tooling to generate the trigger and the brokers and the.
So the trigger and the brokers have been generated from a router of type content based. So we have different type of routers, but some of them are used purely for just filtering data. And this one is more elaborate in the sense that there is no router or there is no content-based router CRD in this cluster, but this is going to use purely Knative objects.
Okay, so there's no TriggerMesh controller in the data path right now in the YAMLs that you created?
No, there is only the data target. Basically, the Slack target is something from TriggerMesh. So if you look at target Slack, this is a controller that we've built to actually process events, dump them into a channel. Oh, I have received my events from Azure. So I'm going to conclude this was a sockeye bug. So my events have been received here in this channel, and this integration is the Slack target from TriggerMesh. But apart from that, there is nothing in the data path from TriggerMesh, no, except for maybe the functions. So if you think about the function as being in the data path, you can. But at the end of the day, these functions are not really, backed by how to say that, backed by TriggerMesh software, but they're just backed by Knative services, right? So I have one Knative service, Slack target chat notification, and I have another one, Azure blog to Slack. No, so sorry, those two are backed, are what is created by the actual function. So yes, they're in the data path somehow, but they're backed by a Knative service.
Okay.
So one last thing I would like to show is that you can also visually see your bridge by not calling till generate, but by calling, for example, till graph. So this is still very much alpha because it generates graph VS code, which is not very pretty. But if you call till graph, you will have basically a graph viz representation of your bridge. And if you go to a tool like the graph viz visual editor, you will be able to represent it graphically like this. So it's a little bit like a little helper when you're designing your integration. Right. And
yeah, this came up in the Omer in the user experience this week on diagrams for the website. Cool.
The thing that came up was that people, like when they're building these sorts of functions experience, like a front end is really important because they want to see how these different components are interacting, especially as they get more complex. So I think it was a great move on y'all's part to put this in.
Yeah, so it's a feature I would really like to see, being improved, and I have something which is actually more dynamic. There are a few things like that for Terraform, for example, where you can observe the actual system which is going to be applied by Terraform, but it's very interactive in the sense that you can click on every node and you can see exactly the configuration of each node. You can move them. It's something which is really lacking from this graph viz visualization, but I mean, personally, it helps me a lot when I'm building these little systems and I'm playing a little bit with different configuration. So I think this is a good first step and a good direction, but obviously not enough for this UI kind of user story.
I put a question in the chat earlier. Is this something that that you all would want to upstream if there was community interest, or is this not the case? Either is fine, just wondering.
At this point, it wouldn't make much sense because we have a lot of hard-coded thing. So if you navigate to, for example, the documentation of this, which is by the way open source, right? You can go to github.com TriggerMesh till. I will show you the link in one last slide, but there are a bunch of integrations which are TriggerMesh specific and even sometimes closed source. So if I look here at for example, the Azure integration I just showed you is at the moment still closed source. And if you navigate to the documentation, you will be able to use that on the TriggerMesh platform. But if you were to deploy that to a, just bare plain Knative cluster, you wouldn't be able to. But with that being said, we're interested in exploring, plugins where you could, just like Terraform, but in a simpler manner, just inject your own kind of resources or build your own little patterns if you wanted to. And then you would be able to, take this tool, use it anywhere. I mean, technically, yes, you could already use it anywhere, but some things will not work.
I guess my real question was around the router object. I think that's a really cool implementation.
Router is usable anywhere. Yeah, I mean,
okay.
Router target also. Yeah.
Target if it's supported. So if you have the Slack target by TriggerMesh deployed in your cluster, yes, it will work. But if not, you will have an error when you try to deploy it. So this one is open source though. So I think, no, it's not open source yet, but a few sources are open source and you could technically deploy them, but they're not part of the Knative core.
Gotcha. Cool.
Yeah. So yeah, we have a few more things. Like I said, if you just want to operate some filtering, but this time on the data, currently Knative doesn't support doing filtering on the actual payload. You could interpolate a router of type data expression filter between, let's say, a source and a target or anything really. And use these little conditions which are based on the cell language by Google. So you can basically filter some events based on this conditions on the data and not only on the cloud event attributes.
Who will be doing that work? That's why I was asking about data plane. Like, is that you create a Knative function that has that snippet of code inside, or you have a controller that scales multi-tenant?
So this is similar to the function, yes. So we do have a data expression filter actual object in Kubernetes, and it will also be using a controller and an adapter that we build ourselves. And I do believe this one is actually open source.
So it will be a TriggerMesh pod implementing an adapter. So meaning like if there's 10,000 requests or events going through that adapter, that they need to scale. That a TriggerMesh component, or that's a Knative service?
That's what I'm trying to get to. Knative service, yeah.
Okay.
Yeah.
So it's Knative service scaling.
It's
okay.
I mean, pretty much everything is backed under the hood by a Knative service, but the Knative service is just doing the scaling, and the actual runtime or image code which is running in the container is from TriggerMesh.
Yeah. Implementing the processing of the data. That's okay.
Yeah. And we did the same for the splitting pattern. So splitting pattern is basically you have an event coming in, it contains multiple items. So think about what you do when you, list virtual machines in AWS or do a kubectl get. You get a list of items and you want to split them into multiple events. You can do that with a splitter type, for example. So the splitter type takes a path. So .items will split everything under items array into a different events. And you can also set the cloud event context for this. So which type every splitted event should have, which source and extensions if you want to, and so on. So this is what we mean when we talk about enterprise integration pattern. These are this kind of little things that we try to abstract, and provide you as a reusable component.
And they're called routers, not transformers.
No, yeah, I know. This is some feedback we already had, and the reason for that, if I get back to my slides, I will. Let's go back to the slide very quickly. share. So yeah, like I explained before, we are based on this integration patterns, and we really, we're sticking to these 5 different categories of, different endpoints for source and target. And then you have 3 categories in the middle, which are routing, channels, and transformation. So maybe we've been doing that by the book a little bit too much. And I agree that seeing a router type for something which is doing filtering, it's not very natural. So we do have transformers, and maybe something like a splitter would be better in this transformer category. So let me get back here. The different categories we have: channel, router, transformer, sources. Transformers,
I see splitter there under message. Message routing, I see splitter there. So yeah, I follow them.
Yeah, exactly. This is message split. Yeah, exactly. This is the reason why it's in the routing. But in this case, we should, I think, take some liberty and do it a little bit differently. Like, yeah, splitter here. The splitter should probably be a transformer and not a router. So, but that's really good feedback. And we've already heard that before.
No, it depends. If you're familiar with the website where you get the integration patterns, which is a huge website you go through, it's very deep, right? You're familiar with that, then that would make sense. If somebody that's not familiar with that, it may not make sense. So yeah. And router is, if going by that book, yeah, it's a router under that category.
Exactly. Yeah. Okay, last thing I actually forgot to tell you about, but this is one of the most powerful thing in my opinion, is the possibility of configuring the delivery guarantees and retries and dead letter queue or sync at the scope of the entire bridge. So if I were to, inject this delivery retries under my bridge block, I would get, wherever it's actually relevant, I would get either a channel interpolated between 2 components automatically. I don't have to do it. And if you use, for example, a broker, which also is conformant to this delivery spec, you would also have it configured with this. So it's I can actually show you. If I get back to the other screen. Sorry, it's a little bit of switching, but screen 2. So if I get back to this bridge description here, remember I had a naked bridge block, which is simply a name, but if I add some delivery block here, even without any kind of setting, and I generate that, then I will have a couple of extra configuration injected. So maybe that's color coded a little bit. So if I scroll to my broker, for example, no, sorry, I do have to define, let's say, retries. So retries equal to, I generate my bridge, and I do have, for a couple of, for example, wherever I have a channel and a subscription, I will have this delivery of 2, which will be interpolated here. Or in the broker, I should also see this delivery retry 2. So basically everywhere where it's relevant, you will have, like I said, either the channel interpolated or the configuration on objects that actually support it. And likewise, you want to configure a dead letter sync. So let's say I want to send every failed message to sockeye, which is a terrible ID, but in this case, for this example, it should be okay. You will have this delivery here injected with a dead letter sync configured for you, where the reference is actually a Knative service, sockeye, and on the broker, it should be there as well. You see delivery, dead letter sync, blah, blah, blah. So that's another of the powerful thing you can do, I think, with this language. And which is very targeted at Knative, one more time. Okay, folks, I'm way over time, but I hope you found it interesting. I will get back to my slides, maybe.
Thank you so much, Antoine. I would like to ask if anyone has another question, we can still get into that. But if not, let me just quickly launch the survey, and please, if you could let us know how did you perceive this presentation. And yeah, so in the meantime, if you have any question, please go ahead. Gabriel saying really awesome stuff, Antoine.
Thank you very much. Very kind of you.
I had one question. With the translation from the TIL to the YAML, is any of that happening server-side, or it's all client-side in the CLI itself? It's
all client-side. We do have plans to, for example, look at the cluster to know what API versions are available. So if you have, an old version of Knative which supports only V1 beta 1, we would like to not generate V1 because you will not be able to run it. This is the kind of example, but I would say as Knative is transitioning to V1 already, this is less relevant now, but it might still be if you have custom integration. So, but currently it's still hard-coded, purely client-side.
Thanks.
Anthony, a quick question. So you said that some things are available only in the TriggerMesh platform. Does the project has a very simple example or hello world example that I can run like in my Knative in kind locally without requiring me to run it on a TriggerMesh? Something that is a hello world or that a tutorial?
Yeah. So the actual documentation that we do have on, I will share my screen again. So the documentation I was showing you before here, as for example, back to the home, starts with a page called concepts with a sort of hello world example, and the GitHub source is definitely upstream, so you would be able to run that. You would be able to define a bridge with the GitHub source, and then you would be able to, for example, use something like a content-based router that you would be able to do. Regarding the event sync, I do believe you could only use Kafka sync because I think this is the only one which has been upstreamed at Knative. All right, so there will still be limitations, but you will definitely be able to send events to custom containers because in the list of targets here, we have something called container. And a container is simply, an image that you define whether it's public or not. You can define some environment variables, but that's really it. You cannot define anything else. It's very simple abstraction on top of one more time Knative service. And you would be able to use that as an event target. So yes, there are still a fair amount of things you can do, even without running on TriggerMesh.
Okay, it's just for learning purposes, like getting Hello World up and running and not being an expert on this language.
For this type of Hello World, definitely. Anything which is routing or event sources which are open source or upstream even, or the Kafka event sync. So it's called a Kafka target in this case, but it's really the upstream one from Knative by Pierangelo, I think. This one is available as well.
Yeah, I'll try Kafka then. Cool.
Kafka target is Pierangelo's Kafka sync, yeah.